The Philippine Atmospheric, Geophysical and Astronomical Services Administration is the national meteorological and hydrological services agency of the Republic of the Philippines, mandated to provide protection against natural calamities and to ensure the safety, well-being and economic security of all the people, and for the promotion of national progress by undertaking scientific and technological services in meteorology, hydrology, climatology, astronomy and other geophysical sciences. Created on December 8, 1972 by reorganizing the Weather Bureau, Pagasa now serves as one of the scientific and technological services institutes of the Department of Science and Technology History. The Observatorio Meteorologico de Manila, formal meteorological and astronomical services in the Philippines, began in 1865 with the establishment of the Observatorio Meteorologico de Manila, in Padre Faura Street, Manila, when Francisco Calina, a young Jesuit scholastic and professor at the Ateneo Municipal de Manila, started a systematic observation and recording of the weather 2 or 3 times a day. Jamie Nonnell, another Jesuit scholastic, wrote a brief treatise on these observations, which was printed by the Diario de Manila. The treatise attracted the attention of businessmen in Manila, and a request was made to the Jesuit director, Fr. Juan Vidal, S.J., for regular observations for the purpose of warning the public against approaching typhoons. The businessman financed the procurement and acquisition of an instrument called the Universal Meteorograph, which would greatly aid in the day and night observations of the weather. In 1866, Federico Faura, S.J., became the director of the Observatorio in recognition of scientific abilities. During this time, the Observatorio was engaged in the systematic observation of Philippine weather. On July 7, 1879, after data comparison with another Jesuit friar in the West Indies, the Observatorio issued a warning indicating that a tropical cyclone was crossing northern Luzon. The colonial government took every possible precaution based on the reliability of the warning, and the slight losses from the typhoon finally and permanently cemented the reputation of the Observatorio. This was followed by a prediction in November of the same year that a tropical cyclone will pass by Manila. The Observatorio began conducting seismological and terrestrial magnetism observations in 1880. In 1885, the Observatorio started time service and a system of visual weather warnings for merchant shipping. In 1886, the Faura aneroid barometer was released. In 1887, a section devoted to the study of terrestrial magnetism was set up, and 6 years later, the first maps of terrestrial magnetism in the Philippines was published. In 1890, the Seismological Service was officially established, and in 1899, the Astronomical section was opened. This reputation reached foreign shores, and other observatories began requesting for the monthly Bulletin del Observatorio de Manila. The growing demands for the services of the lead Observatorio led to the issuance of a royal decree on April 21, 1894. This effectively recognized the Observatorio as an official institution under the Jesuit order, with full support from the Spanish crown. This led to the establishment of a network of secondary stations in various points of Luzon. American period. The Weather Bureau, under the Treaty of Paris, on December 10, 1898, Spain ceded the Philippine Islands to the United States of America. After a period of great political turbulence that climaxed in the outbreak of Philippine-American War in 1899, an insular government was established. On May 22, 1901, the Philippine Commission enacted Act No. 131. Reorganizing the Observatorio Meteorologico de Manila into the Weather Bureau under the Department of Interior. With the establishment of the Department of Agriculture and Natural Resources on January 1, 1917, the Weather Bureau was transferred from the Department of Interior to DANR. With the establishment of the Commonwealth of the Philippines, the DANR was reorganized into the Department of Agriculture and Commerce. For nearly 45 years, the Weather Bureau remained active and famous in international expositions and scientific expeditions, and continued to be well known for its accurate typhoon forecasts and scientific works in the field of meteorology, geomagnetism, and astronomy. The first weather map in Far East became an important tool in tropical cyclone forecasting thereon. The Bureau's published works on meteorology, terrestrial magnetism, and astronomy were well known and had later proven to be of great value to the American forces in the liberation of the Philippines from the Japanese during the Second World War. Second World War. On October 4, 1943, with the establishment of the Second Philippine Republic as a puppet state of Japan during its occupation, the Weather Bureau was transferred to the Department of Public Works and Communications. The Bureau was removed from the direction of the Jesuits, and for the first time, the Bureau had an all-Filipino staff headed by Mr. Maximo Lashica, head of the Department of Geodetic Engineering of the University of the Philippines. The Japanese occupation period marked limited activity in the central office. However, in the field, Bureau personnel were instrumental in bringing accurate weather information over enemy-occupied territory to the American Liberation Forces. On February 1945, the Second World War brought the operations of the Weather Bureau to a catastrophic halt when its officers were destroyed during the Battle of Manila. Nothing but the burnt-out shell of its astronomical dome in Padre Faura Street bore testimony to its once glorious past. All the instruments, records, massive scientific knowledge accumulated through the decades were lost. After the war, the Observatorio ceased to function as the Weather Bureau. The former would later resume independent operations in 1951 as the Manila Observatory. Post-war era. Rebirth. The rebirth of the Weather Bureau began on July 24, 1945, when it was re-established by 7 constituent personnel under the leadership of Edilberto Paralan as officer-in-charge. In 1946, pursuant to the Tidings War Damage Act, a U.S. Weather Bureau mission was sent to Manila by the United States government to undertake a survey of the needs of the Weather Bureau. As a result, the Bureau was able to acquire meteorological equipment and technical assistance from the United States that paved the way for the establishment of standard weather services patterned after similar meteorological institutions in more technically advanced countries. Furthermore, the Weather Bureau was transferred to the Department of Commerce and Industry. The Bureau's functions were then carried out by 5 divisions. In 1947, the central office of the Weather Bureau was moved to Mars Main Building, while the Forecasting Center was transferred to the old Balagbag Terminal and became the Manila Main Meteorological Office. The first post-war geophysical observatory of the Bureau was established in 1949 behind the campus of the University of the Philippines in Diliman. In 1948, a set of electromagnetic photorecording seismographs was installed in order to improve its seismological services. On April 5, 1949, the Philippines was admitted into the World Meteorological Organization, with the Weather Bureau as its national meteorological service. In the same year, temperature, relative humidity and pressure observations in the upper upper atmosphere were made twice daily by the Laoag, Cebu and Zamboanga field stations. In 1950, a teletype service connected MMMO to Clark Air Force Base, U.S. Naval Station Sangley Point and the Bureau of Telecommunications. Moreover, exchange of weather reports with foreign countries, aircraft in flight and 4 aeronautical stations in the country, Laoag, Legazpi, Cebu and Zamboanga began at this year. Private radio systems and the then National Civil Defense Administration also helped to facilitate the reception of data and dissemination of the forecasts and warnings. In 1954, radio transmissions of time signals began in the Geophysical Observatory. Weather surveillance radar was first installed in the Philippines in 1963 atop the central office of the Bureau. In 1965, on its centenary, half of the weather stations across the country were already linked with each other by single sideband radio transceivers, forming an independent meteorological communications system. In 1968, the Philippines joined the Typhoon Committee formed by the Economic Commission for Asia and the Far East and the WMO. The following year saw the transfer of the central office from the Marsmin Building to 1424 Quezon Boulevard Extension in Quezon City. The same year also ushered the 5-year WMO Training and Research Project Manila, composed of the Institute of Meteorology in the Weather Bureau and the Department of Meteorology in the University of the Philippines. The project aimed to meet the training needs of the country's meteorological personnel and to carry out research in various fields of meteorology. The institute provided technical in-service training in various levels, while the department offered a postgraduate course leading to a Master of Science degree in meteorology. With the implementation of the project, the acquisition of an IBM 1130 was realized and computerization in the Bureau came of age. A telemetry system in the Marikina River Basin was then set up, which led to the Bureau's initial efforts in flood forecasting. Satellite meteorology came to the Philippines in 1970 when an automatic picture transmission system was set up to intercept photo transmission of the upper atmosphere by weather satellites. The first post-war major research initiative of the Bureau was launched in the same year, called the Typhoon Research Project. It was launched in 1970, was made possible through the financial assistance of the National Science Development Board. In 1971, upon invitation of the Philippines, the ECAFE-WMO Joint Unit was reallocated in Manila and was rechristened as the Typhoon Committee Secretariat. In the same year, the linking of 5 weather surveillance radars installed across different parts of the country and the Manila radar station paved the way for the weather radar surveillance network of the Bureau. Marcos era, from Weather Bureau to Pagasa. In 1972, at the height of martial law of President Ferdinand E. Marcos, the Weather Bureau was abolished and a new agency, the Philippine Atmospheric, Geophysical and Astronomical Services Administration, was established pursuant to the Atmospheric, Geophysical and Astronomical Science Act of 1972 as part of the Integrated Reorganization Plan of the Philippine government. This new agency was placed under the authority of the Department of National Defense. 4 organization units initially comprised PAGASA. The National Weather Service undertakes the preparation and subsequent prompt issuance of forecasts and warnings of weather and flood conditions. The National Atmospheric, Geophysical and Astronomical Data Service undertakes the acquisition, collection, quality control, processing, and archiving of atmospheric and allied data. The National Geophysical Geophysical and Astronomical Service undertakes observations and studies of seismological and astronomical phenomena, as well as provides the official time for the country. The National Institute of Atmospheric, Geophysical and Astronomical Sciences is responsible for the training of scientists and technical personnel with respect to atmospheric, geophysical and astronomical sciences. In 1977, the Typhoon Moderation Research and Development Office and the National Flood Forecasting Office were placed under administrative supervision of PAGASA, pursuant to Presidential Decree No. 1149/S. 1977. PAGASA saw a lot of accomplishments during the Marcos era. In 1973, the Pampanga River Basin Flood Forecasting and Warning Project, a joint undertaking of the PAGASA and the Ministry of Public Works, Transportation and Communications, was inaugurated, and upon recommendations of a survey mission, the Japanese government provided the equipment and training of personnel for the project. Early in 1974, PAGASA, in cooperation with the Office of Civil Defense, put up a radio station with call sign DZCA, through a network of automatic stations situated at strategic points along the Pampanga River and its major tributaries. Data on the rise and fall of the river levels are sent to the Flood Forecasting Center in the central office via existing telemetry system. Impressed with the success of the flood forecasting system in the Pampanga River Basin, President Marcos instructed PAGASA to explore the possibility of putting up a similar system in the Agno, Bicol and Cagayan River basins. The UNESCO-sponsored Regional Seismological Network in Southeast Asia set up an office in the PAGASA Geophysical Observatory in 1974. It sought to standardize the training of personnel and seismological equipment, as well as to improve the accuracy of determining the epicenters of earthquakes in the region. Subsequently, in 1977, a strong motion accelegraph network was put up in Metro Manila. The network was designed to record strong earthquake vibrations in the area. On April 18, 1979, the Science Garden Planetarium was opened to the public. Equipped with a multiplanetarium projector, it has a seating capacity of 90 people. In June 1981, the Bicol flood forecasting subsystem based on the Pampanga River system was inaugurated. In May of the following year, all three subsystems became fully operational. On the same occasion, the ground receiving station for the geostationary meteorological satellite was inaugurated, bringing the satellite meteorology of the Philippines to a giant leap forward. In April 1983, flood forecasting and warning system for dam operations was jointly undertaken by PAGASA, National Power Corporation, and National Irrigation Administration, with financial assistance in the form of loans from the Japanese government. Phase 1 of the project covered Angat and Pantabangan dams, while Phase 2 covered the Magat, Bingo, and Ambuclao dams, as well as the Data Information Center for the project. The subsequent efforts of the government to centrally direct the integration of all government scientific and technological efforts led to the transfer of PAGASA to the National Science and Technology Authority through Executive Order No. 984/S. 1984. The reorganization also transferred the seismological services of PAGASA to the Philippine Institute of Volcanology, now Philippine Institute of Volcanology and Seismology. Post 1986, PAGASA Today. Following the re-establishment of the democratic government after the ouster of Ferdinand Marcos in 1986, President Corazon C. Aquino ordered the reorganization of the National Science and Technology Authority and all agencies under its authority, pursuant to Executive Order 128/S. 1987. 5 major branches and 3 support divisions now constitute PAGASA. This organizational structure remained until October 2008, when the agency went under a rationalization program pursuant to Executive Order 366/S. 2004, issued by President Gloria Macapagal-Arroyo. The rationalization program of the government was aimed at making the government focus its efforts on vital core functions and enhance effectiveness and efficiency of public service. On January 15, 2003, PAGASA transferred its central office from 1424 Quezon Avenue to its permanent headquarters at the Science Garden, located along Agam Road in Diliman, Quezon City. Meanwhile, scientific and technical operations are currently being undertaken in its Weather and Flood Forecasting Center, a facility located just in front of its current headquarters. On November 3, 2015, Republic Act No. 10,692, or the PAGASA Modernization Act of 2015, was signed into law by President Benigno Aquino III. The government will initially spend 3 billion pesos from the PAGCOR revenues for the Modernization Fund of the State Weather Bureau. That includes the upgrading and acquisition of equipment, new salary scheme for the employees, manpower training for future weathercasters, and the creation of PAGASA data center, among other plans. Tropical cyclones. PAGASA monitors tropical cyclone activity and issues warnings if they fall within the Philippine Area of Responsibility (APA). This area is bound by an imaginary line drawn along the following coordinates: 25 degrees north, 120 degrees east, 25 degrees north, 135 degrees east, 5 degrees north, 135 degrees east, 5 degrees north, 115 degrees east, 15 degrees north, 115 degrees east, 21 degrees north, 120 degrees east, and back to the beginning. Tropical cyclone bulletins are issued by PAGASA every 6 hours for all tropical cyclones within this area that have or are anticipated to make landfall within the Philippines, or 12 hours when cyclones are not affecting land. As of May 20, 2015, PAGASA used to classify tropical cyclones into 5 categories: tropical depression, maximum 10 minutes, sustained winds of 30 to 60 km per hour; tropical storm, maximum 10 minutes, sustained winds of 61 to 88 km per hour; severe tropical storm, maximum 10 minutes, sustained winds of 89 to 117 km per hour; typhoon, maximum 10 minutes, sustained winds of more than 118 km per hour; super typhoon, maximum 10 minutes, sustained winds of more than 220 km per hour. Tornadoes. On August 27, 2007, PAGASA announced that it was putting up a tornado warning system, days after several more powerful and destructive tornadoes damaged houses in central Luzon. The monsoon and climate change. On August 23, 2007, a second tornado destroyed 30 houses in 4 villages in San Miguel, Bulacan, the first having damaged 27 houses in San Rafael on August 8. However, as of present time, the Weather Bureau has yet to provide such warnings. Climatology. The climate of the Philippines is discussed in detail on the climatology page of the PAGASA website. PAGASA lists patterns of temperature, humidity, rainfall, seasons, and 4 climate types for the Philippines. Climate types are: Type 1-2 pronounced seasons, dry from November to April, wet rest of the year. Type 2 no dry season, but with heavier rainfall from November to January. Type 3 seasons are not very pronounced, relatively dry from November to April, and wet during the rest of the year. Type 4 rainfall is more or less evenly distributed throughout the year. Criticism. On August 6, 2010, President Benigno Aquino III announced the removal of Prisco Nilo as the administrator of Pagasa. Pagasa was directly under Department of Science and Technology under Secretary for Research and Development Graciano Umal. A special order from DUST Secretary Mario Montejo, dated August 5, 2010, designated Umal as the new Pagasa administrator. Nilo was criticized for lack of modern equipment, forecast inaccuracies, slow voluntary response and the aftermath of Typhoon Ondoy in September 2009, and Typhoon Basiang in July 2010. Doppler weather radar, weather stations and other equipment. Pagasa installed its first Doppler weather radar station in Baler, Aurora and another in Baguio. The new weather radars can monitor the typhoon and its movements, amount of rainfall, either moderate to heavy, and real-time atmospheric forecasts using a visual radar monitor. An example was that of Typhoon Basiang in 2010. Data used for warnings through Project NOAA since June 2012. Pagasa has installed at least 10 Doppler weather radars in the country. Currently operational stations are as follows: Luzon, Apari, Baguio City, Subic, Baler, Tagaytay, Virac, Visayas, Mactan, Huiwan, Mindanao, Tampakan, Hinatuan. Moreover, the Weather Bureau is now constructing 4 to 5 more Doppler weather radar stations in Busuanga and Quezon, Iloilo, Zamboanga City, Abasco. It aims to have 13 operational radar stations nationwide by the end of 2013. Before Nilo's leave, an automated rain gauge was also installed in a telecommunications cell site in Montalban, Rizal, to monitor excess rainfall as a warning signal to avert the effects of flash floods and landslides by using cell phones. The Weather Bureau plans to adopt its swift transfer of data from ground forecasting stations to main headquarters utilizing its automated data acquisition system modeled after Japan Meteorological Agency AMADAS in the near future as a solution to forecast inaccuracy and the problems. The Japan International Cooperation Agency will provide modernization programs to enhance the services of Pagasa, include meteorology and flood forecasting, and tornado warnings as precautionary measures. 7 new Doppler weather radars placed in different locations are scheduled to operate in June 2011. In addition, the Weather Bureau introduced its landslide early warning sensor to reduce landslide casualties in case of landslides. Using this new device, the sensor picks out signals in the form of computer data to show soil and ground movements and is transferred to the ground station immediately in an event of a landslide. And in order to launch forced evacuation, Pagasa hopes to install 10 sensors in 5 landslide-prone areas by 2012, when it is tested and ready to bury on ground. Another innovation to flood alerts was the adoption of an automated weather station designed to monitor amounts of rainfall and flood levels in case of an incoming warning. The AWS can be controlled by computer even it is unmanned, and a siren to evacuate people for emergencies. Few of the AWS units are installed in few points of the country, and many more units will be installed to extend its coverage. In 2011, Taiwan donated 15 weather stations to the Philippines Department of Science and Technology, and it has been reported that the Philippines Weather Bureau will also share information from the new weather stations with Taiwan's Central Weather Bureau, helping expand the range of Taiwan's weather forecasts. Pagasa and the Philippines Department of Science and Technology work jointly in the implementation of weather stations.